For the longest time, we've thought of computing as something that happens, well, down here, on the ground, right? It's in our phones, our laptops, these giant data centers. But what if that's all about to change? What if the next huge leap in computing power isn't stuck in some building, but is actually flying right over our heads? Yeah, today we are diving into this wild idea of the flying cloud.
Okay, let's start with something we've all been through. You get a cool new app, right? Maybe it's some amazing augmented reality game or a pro-level photo editor for your phone. And you can literally just watch that battery percentage drop like a rock. It's this constant battle, isn't it? Our apps demand more and more power, but our phones are stuck with these little batteries that just can't keep up.
So we're all used to the idea of the cloud, right? We send our stuff to it, to some server farm who knows where. But what if the cloud wasn't a place you send things to? What if the cloud could actually come to you? I mean, right to where you are whenever you need it. That one little question, well, that's where this whole crazy idea gets started.
And to really get our heads around this, we're going to follow the breadcrumbs of the research. We'll start back in 2016 with this first idea of a single flying cloudlet. From there, we'll see how that leveled up into a whole coordinated swarm, then how it blew up into a global paradigm, and finally, how researchers today are trying to give this flying network an actual AI brain. It's quite a ride.
So let's dig into that core problem a little more. The early research really zeroed in on this tension, right? The powerful apps versus our poor tiny batteries. It's a fundamental bottleneck. Plain and simple. We want our phones and tablets to do amazing, high-powered stuff, but the hardware inside just can't. Not without the battery just completely giving up. Now, the classic solution to this has a name: task offloading. And it's pretty much what it sounds like. Instead of your phone sweating to do all the heavy lifting, it offloads the really tough part of the job to a bigger, more powerful computer somewhere else. That computer does all the hard work, crunches the numbers, and just sends the final answer back to your phone. The key thing to get here is that this saves a ton of your phone's energy and usually gets the job done way faster.
Okay, so here's where it gets interesting. The big idea right at the start was, what if that more powerful computer wasn't stuck in a building? What if we could make it mobile, untether it from the ground, and give it wings? And that brings us to the first huge breakthrough, back in 2016, literally just putting a computer on a drone.
Of course, researchers had a fancy name for it, a UAV-mounted cloudlet. But I mean, don't let the name fool you. It's exactly what you're picturing. A tiny mobile data center, they call it a cloudlet, strapped onto a drone. The whole point was for it to fly to you, give you that processing power right when you need it, and, most importantly, save your phone's battery from dying.
It's a pretty cool concept when you think about it. The best way to picture it is like a personal data butler that flies. So, say you need to render some super complex 3D model on your tablet. Instead of your device grinding to a halt and chugging battery, you just summon your flying butler and it handles all the heavy lifting for you. Simple as that.
All right, now let's jump forward a few years to 2020, because this is where the idea starts to get way bigger. I mean, a single flying computer is neat, for sure, but what happens when you have a whole fleet of them? This is where things really start to scale up. So researchers figured out that a whole swarm of these drones could actually work together. They could form their own temporary, self-organizing cloud, and that's the key insight here. They could create what's called an ad hoc cloud, which is just a fancy way of saying a pop-up data center. And the coolest part? It can work even when there's no internet. You can imagine how useful that would be in a remote area or, say, a disaster zone. And this really shows you how the thinking changed. That first idea, the single drone from 2016, that was all about helping one person save their phone battery. But the drone swarm, now we're talking about totally new, complex, collaborative jobs. Think about a whole team of drones working together to create a super detailed 3D map of a forest after a wildfire. The scale of ambition just exploded.
Okay, so we've got a swarm. Now, what if you took that swarm concept and just scaled it up to cover the entire planet? The latest research imagines a world where this flying layer of computers doesn't just do its own thing, it's fully integrated with everything, the cell towers on the ground, and even satellites way up in space.
This whole vision has a name, of course. It's called a Space-Air-Ground Integrated Network, or SAGIN for short. And it's basically a 3-layer cake of technology. On the bottom, you've got the ground layer, your normal cell towers. In the middle, you have the air layer, all the drones and flying platforms. And on top, you've got the space layer,
low Earth orbit satellites. And the whole point is to make these 3 layers work together as one single, seamless network for all our computing and communication.
And the end game here, the ultimate goal, it's summed up perfectly by this quote from some researchers looking at future 6G networks. They said, "The vision is for users to feel like they're surrounded by a distributed computer, where any request you make is fulfilled instantly, with apparently zero latency." I mean, just think about that. It's the idea of an invisible, all-powerful computer that's just everywhere, all at once.
Yeah, so building an invisible, all-powerful computer that fills the entire sky, turns out that's a little complicated. And this brings us to the huge challenges that researchers are wrestling with right now. I mean, how on earth do you manage a network that is this complex and is constantly moving?
The real-world hurdles are just massive. How do you deal with network lag when your servers are literally flying around? How do you decide which of the thousands of drones gets the next task and do it in a split second? And oh yeah, how do you make sure the whole thing is secure? It's a logistics puzzle on a scale that's almost hard to wrap your head around.
So how do you solve a problem that big? Well, the answer that's bubbling up from all the research is artificial intelligence, specifically something called deep reinforcement learning. The best way to think of it is like you're training an AI to be the ultimate conductor for this giant flying orchestra. It learns by trial and error, making millions of tiny decisions every second. Which drone gets what data? Which route is fastest? It gets rewarded when things are efficient and speedy. And over time, it just learns how to perfectly orchestrate all those moving parts in real time. So let's just step back and pull this all together. It's kind of wild, right? We started with a really simple, everyday problem, a dying phone battery. And we've ended up here talking about a global, 3-dimensional, AI-managed network of flying computers. That is a massive leap in thinking.
And here's the most important takeaway from all of this. This isn't just about making faster drones or better batteries. No, this is a fundamental shift in how we think about computing itself. A paper from 2022 finally put a name on it: aerial computing. It's a whole new paradigm, one where processing power isn't locked down on the ground or in some far-off data center, but is a dynamic, mobile resource that's literally in the air all around us.
And that leads us to the final, really mind-bending question. Look, this technology is still pretty new, but the implications are just staggering. So if computing is no longer chained to the ground, if it becomes this flexible, on-demand resource you can put anywhere in 3-dimensional space, what will we even build when the sky itself is the computer?